All right, so thank you all for coming. Gonna wait a little bit while everybody gets set up. Um, so today we're gonna be doing sum to product formulas. Look something like this. So if you would like to pull that up in your book, take out notes to get ready and follow along, then fabulous. Anybody got any questions about stuff before we get started? All right. Well, I guess we will get started. I'm sure we'll have some more stragglers soon. First order of business is I will be all of the classes from now on will be on this same invite. I set it up, I think, where it should send you a message about the meeting for every class, but every time it's going to be the same, this same link, because it's a recurring meeting. So yeah, so if you ever aren't sure how to get there, it will probably show up in your Zoom meetings under, let's see. Where is, one, two, three, two. Go with that. Well, that's not very helpful. All right. But it's under my Zoom app. So under recurring meetings. So if you have the if you have that app, I would definitely make sure to check that. But it should also send you something through your email notification. So this is my Zoom app. So these are all the recurring meetings I have. So, all right. Guess that's enough time. We can get started. So, like I said, we're going to talk about sum and product, sum to product formulas. We're going to take a sum of two sines or cosines and turn it into a product of two sines or cosines. And it's basically using the same process as we used last time. Same idea is we're using this kind of fundamental basic relationship of sine is a sine of, we'll say x plus or minus y equals, anybody remember how that one goes? So sine, you kind of think about it as the sine function is the opposite side with the hypotenuse. So it has opposites in it. So it's sine x cosine y plus or minus sine y cosine x. So the idea is that, why is that blurry right there? That's weird. I guess that's a TV reflection. All right, sorry. Anyways, so most of the identities that we've talked about come from using either this one or the other one, which is cosine of plus or minus y cosine x cosine y minus plus sine x sine y. So we're going to use this, we use the same idea to do the previous one, where we go from a product to a sum, which I will show you. So those ones were right here, where you have a product and we're going to turn it into a sum. We're going to use this same kind of relationship to go the other way. So sum to product. One of the things that I'm trying to get across here is not just proving this relationship to you. So don't think that like I'm just trying to create the relationships. This part of math is all about playing with stuff. It's all about flipping things around and manipulating them. And so this is great practice for doing that. We're just doing it with a guaranteed start and end goal in mind. So the first one we're going to do is this one. Sine of u plus sine v. We're going to turn it into this funky looking thing. Okay. So question is, how do we do that? And this is a trick, and I don't know exactly where I don't remember exactly where I learned this trick. I don't even know that someone did teach it to me. But it's one of those things that is actually very helpful in solving different kinds of problems, equations. And it's taking two numbers and kind of converting them into a different set of two numbers. But the different set is actually very useful. So we're going to take any two numbers, and we call them u and v, and we're going to convert them into two numbers x and y. So x is the average of u and v, and y is the deviation of u and v. So that sounds really random, really weird, but give me two numbers between 0 and 100. I'm just going to show you what I mean by this. So what is, somebody give me two numbers between 0 and 100.
5 and 6.
5 and 6, all right. I'll do 5. Give me one that's a little bigger than that.
20.
20, okay. So we're going to go from 5 and 20. We're going to convert it to their average and their deviation. So let's, just for simplicity's sake, let's do 6 and 20. Doesn't really matter, but all right, so the average of these two numbers, x, what is the equation for the average of two things? How do you find the average of things?
Don't you got to add and divide?
Yeah, you add them up, so U plus V, and you divide by how many there are. In this case, it's just 2. So that equals 6 plus 20 over 2 equals 13. Then we're also going to have their deviation. So this one is the one that's a little weird because I call it a deviation, but you're basically saying the two original numbers are this far on either side of their average. So 13 is the middle of these two. So how far away are they both from the middle? And the way you find that is, and this is why this thing is helpful, is it looks a lot like the average, but it's a little bit different. No. So what does that equal?
7.
7. All right. So instead of talking about these just two random numbers, we talk about them in terms of their average or their middle point and how far away they are from that middle point. So realistically, they're both, all of the information that was here is still here. It's just in a slightly different form. Okay. So what? Who cares? Why are you giving this random little bit? I'll tell you why. So let's do that with this. We're going to go from U to X and Y. For simplicity's sake, just because it'll make the math a little bit easier, we're going to define them to be, where's my notes? Yeah, so we're going to find X to be U plus V and Y U minus V. So it's just their average and their deviation multiplied by 2. You'll see why that I didn't put the extra 2 thing in there in a second. Well, when we do this, let's look at what this becomes. This becomes sine of what? Sorry, let's go the other way. What does U equal? If you put it into this, it becomes X plus Y over 2. If you solved these two things for U and for V, you get back that relationship. If you plug this in, sine of U is sine of x plus y over 2. We do plus sine of x minus y over 2. And from here, we use the same formulas that we have in the past. So that sine cosine addition formula, when you have sine of plus and sine of minus, where'd those formulas go? I'm going to share. So we have sine of something plus sine of something else. Sine of something plus sine of something minus something. And then divided by 2. Should give us sine of that thing and cosine of that thing. So we're just taking, after we did our little trick and our little substitution, we're just taking the formula that we already figured out to go back the other way. So when we do this, it looks like where's my stuff? Sorry, I'm having some technical issues. Stuff is going to sleep on me. So we have this one, sine of u plus v, sine of u minus v, which means that this thing should go to sine of, oh, I'm sorry, 2 sine of u plus v cosine of u minus v. Okay, but again, it's just based off of that previous relationship that we had. More people coming in. So in this one, we were allowed to switch the argument from something that we can't really do something with, because we don't have a relationship for sine of a thing plus sine of a different thing. We don't have a direct relationship for that. But what we do have is sine of something plus something, sine of something minus something. So we use that fact to our advantage. So we're kind of working it almost backwards. We said that u plus v was x, and u minus v was y. So we just took this one basic relationship, and if we want to do the subtraction one, we get this. Hate that. Sine of u plus v minus sine of u plus v ends up being cosine of u sine of v. So let's do a example real quick of this process. Where'd it go? So this is going to be the problem down here at the bottom. So we're going to find the exact value of cosine of 195 degrees plus cosine of 105 degrees. So cosine of 195 cosine 105. All right. So what do we use? So we have a formula where cosine of x plus cosine y equals 2 times cosine of the average and cosine of the deviation. Hope y'all can see that. I'm getting some weird blur going on. This is what I was talking about a second ago, about going from the two numbers, just x and y, and converting them into their average, x plus y over 2, and their deviation, which is x minus y over 2. So what is the average of these two numbers? Anybody? Average of 195 and 105. No.
Would the first one, would the first one be 2 cosine 150?
Yep. Average.
And then
And then what is their deviation? What is, subtract the 2, what do you get?
90.
90. And what's 90 divided by 2?
45.
45. Okay. And according to our unit circle, what are either of these things? So you could do this.
I know the cosine of 45 is √2/2.
Okay. What about cosine of 60? You have a 30, 60, 90 triangle. This is 60 and that's 30 and that's 90. So this is 2.
Would that be
What are the other
√3/2?
sides? What?
60. Well, the side opposite of 60, wouldn't that be √3?
Yep.
The other side is 1.
Yeah. So what is the negative cosine? Oh, I'm sorry. This is supposed to be, when you convert it, negative cosine of 30 degrees. I used the cosine of theta equals negative cosine pi minus theta, or 180 minus theta. So what is cosine of 30?
1/2.
Cosine of this.
Oh, √3/2.
Yeah. So we get 2 negative square root 3 over 2 times square root 2 over 2. What do we get?
Would that be
Never mind.
Well, what's 2 divided by 2?
1?
There's a negative sign in there.
So would it be negative √6/2?
I didn't hear what you said.
Would it be negative √6/2?
That's correct. Square root 6 over 2. Yeah. So again, this is what I wanted to mention about this, is in case you forget how they work, what their different like the different arguments are, is you always, in all of these sum to product formulas, you always go from x, cosine or sine of x plus cosine sine of y, and you always go to something of their average times something of their difference, or of their deviation. Okay, so if you don't like having to remember x plus y over 2, x minus y over 2, just remember they always have both, and the way they've written them in this little table at least, they all have their average and their deviation. Okay, so this is a very helpful thing in trig. So remembering exactly which pair goes with which is not always easy. So that's why it's nice to have a note card. But yeah, so there we go. So let's try and solve a trigonometric equation, or at least start to. Because this is the whole idea behind all this, is where we learn these rules to figure out how to solve stuff. Okay. So sine of 5x plus 3, or sine of 3x. All right. So this is one of the ones that we just learned. And sine plus sine goes to 2 sine of something, and it's cosine. Yeah. All right. So what is for these two?
Would it be 2 sine 4x cosine just x?
So for x, which is 5 plus 3 divided by 2, yep, and just x. Right? Good. Well, now where do we go? Yes. So to me, this looks like a double angle formula. But there's a better way to do it. So this equals 0. So the question is, when does sine of something equal 0? So this happens at 0, pi, 2 pi, 3 pi, on forever. Cosine theta is 0 when?
Like pi over 2.
Yeah. And then
Maybe like pi over 4.